In this lesson, we're going to build on to our factoring methods for polynomials. So you now know how to, or have reviewed how to factor the GCF out of a polynomial. Today, we're going to look at factoring by the grouping method. So let's just review factoring out the GCF, because factoring by grouping will use factoring out of GCFs in the process. So let's review with this binomial here, a type of polynomial. The GCF is the greatest common factor. So we want to find a factor of all the terms in the expression that could cleanly divide out. So if I focus on just my numbers 15 and 20, you can see that they do share a factor of 5 that would cleanly divide out of both of them. Looking at your variables, both terms share an x. So this one's an x to the first, so the greatest common factor of x's that they share is just 1x. So we can pull 1x out, and they do not share any y terms. While this one has a y, this one does not, so we can't pull a y out. So that means the GCF of the terms in this polynomial is 5x, which means when I divide 5x out, or factor it out, I divide each term by the 5x. And inside of the grouping symbols, we should write what's left after factoring out that 5x, so after dividing it out. So this will give us a 3x to the fourth. Bring down your plus sign. 20 divided by 5 is 4. The x's cancel, y cubed. So that is a factored out GCF for that expression, and you do need the entire times whatever's in that parentheses that's left after it's pulled out. You can always check these by multiplying back through and making sure you get back to what you started with. So I will let you try this next one to review on your own, pulling the GCF out of 8x to the fifth y squared plus 12x y cubed. So you should notice both numbers share a 4. They each share 1x at the most and 2 y's. So the GCF is 4xy squared, leaving us with 2x to the fourth plus 3y for the terms. That's what remains after we divide out that GCF 4xy squared. Okay, so that's a review of factoring out the greatest common factor. So let's now build on this and learn the second factoring method for polynomials. This is factoring by grouping. Factoring by grouping can only be used when you have at least 4 terms and then increasing in even increments from there. So by grouping, we can factor when there are 4, 6, 8, 10, 12, and so on. If you have less than 4 terms, however, you will not be able to use this method. So a binomial and a trinomial cannot be used with this method. We will learn methods for trinomials in the coming lessons. So you're looking for at least 4 terms. For example, we have x squared plus 3x plus xz plus 3z. This is a polynomial that has at least 4 terms in it. And so we will be able to use the grouping method to factor. So step 1 is to start by grouping together terms with a common factor. What I hope you notice is that in this example, the 4 terms do not all share one common factor, right? So while I see an x in 3 of the terms, I can't pull an x out as a GCF of the whole expression because my last term does not have that factor of x in it. So that is something, there's no factor through all 4 terms that can be pulled out of everything as a GCF of the whole polynomial. But what I hope you'll notice is that the first 2 terms do share a factor. They share at least 1x, and our last 2 terms also share a factor of z. You might also be noticing 2 of the terms both have 3's. This term and that term can match up. So there are factors that are common between chunks of those terms, parts of those terms, but just not all 4. So what we're going to do is we're going to start by grouping together terms that share common factors. Usually, this will be your first 2 terms and your last 2 terms. So I'm going to group mine together, first 2, last 2. If they share something, then don't worry about rearranging your expression. While you certainly can rearrange it, if the first 2 share something and the last 2 share something, you don't have to do any rearranging. You'll be able to fully and properly factor by grouping. Step 2 is then going to be to look at each grouping now separately. So now treat x squared plus 3x by itself. Kind of ignore this second part for just a moment and factor the GCF out of that first grouping. So the GCF of this binomial is, of those 2 terms, we can pull an x out of those first 2. Now let's look at this last grouping and see what term can be pulled out of these 2. Hopefully you see that both terms there share a factor of z. So what we're going to do is rewrite each of these so that I've pulled the x out and I leave in parentheses what's left after we divide that common factor out of the first 2 terms. Keep your plus sign in between and then write the factor or the GCF of the second 2 terms, the z, and in parentheses, leaving what is left once we divide z out of each term. At this point, I hope you notice something interesting that's occurred. What happens is we're left with the exact, if you've done this correctly, we are left with the exact same expressions, meaning they have the same signs, same variable combinations inside of those parentheses. And this is not a coincidence. This should happen if it's able to be factored with the grouping method. And so in our third step, what we're going to do is now pull the common parentheses out, and the leftover factors form the second parentheses. So this 4-term polynomial is going to factor to the product of 2 binomials. So a binomial times a binomial is what we're going to end up with. So what this is essentially saying is because x is being multiplied by x plus 3, and a positive z is also being multiplied by x plus 3, then x plus 3 in a sense is a GCF of this chunk and this chunk. So we can pull out that common GCF that both x and z are being multiplied by, and we can make the x plus 3, that one that they share, one of the binomials in our answer, and then combine the x and the plus z to make the other binomial in the factored out version of that polynomial we started with. So we are left with an x plus 3, that's the one they shared. You write it 1 time in your answer, and then you combine the GCFs of both parts, the x and the z, to make your other binomial. You can always check if you factored correctly by multiplying back through. So x times x is x squared. X times z is a plus xz. 3 times x, positive 3x. 3 times z, positive 3z. Now it ends up being in a slightly different order, but you can check that the signs match and all terms exist with what we started out with. If it all checks out, then you know you've done it correctly. So that is the factoring by grouping method. So we're going to spend today practicing these. All right, so here's our first practice problem. We've got 10x squared minus 15bx minus 14ex plus 21be. Now step 1 is to begin by grouping the sets of terms that do share common factors. You'll notice there is not a factor that's shared by all 4 terms in this polynomial we're starting with. We do always want to look for a GCF at the beginning, okay? But if we can't find one, then we move on down our factoring list, in this case moving to the grouping method, and see if that will work. So we need to now group pairs together. 10x squared, the first term, and negative 15bx do share a factor of 5 and x. So I can group those two together. 14ex and 21be share terms of e and 7. So those can be grouped together. So there's nothing, I don't need to rearrange to match any of the pairs up. The first two have a factor they share, and the last two have a factor they share. So we're going to group them together. This one, though, is slightly different. Notice that here we had a plus sign in the middle. However, in this one, we have some minus signs. The only one that matters is the one in between your middle two terms, so the absolute most middle sign. If that one is minus, then what we're going to need to do is make sure that that subtraction sign gets applied to the term after it. So this can look a couple different ways. The most common way to show this is to change that subtraction to a plus a negative. We might call this keep change opposite, KCO, that sign to plus a negative 14ex plus 21be. So that now when I group my first two together and my second two together, I still have the plus sign in between the two terms. It's very important that when you do this grouping, you keep that plus sign in between the parentheses. We're not turning this into a multiplication. Okay, and we do want the negative with the 14ex, which will come into play in just a moment. The other way that I will sometimes show this is by just saving from having to rewrite the whole thing. I will group them and then put the plus sign above my two parentheses. So visually I can see there is still a plus sign there, but I'm also linking that minus with the 14, the next term. So you can show that one of two ways, but you must have a plus sign in between the parentheses. So that's step one. Now in step two, we need to factor the GCF out of each of these pairings. So here in the first grouping, there is a shared factor of 5 and a shared factor of x. So I'm going to pull the 5x out and write down what's left once I divide 5x out of each term. So 10x squared divided by 5x is a 2x. Bring down your minus sign. 15bx divided by 5x is 3b. Carry down this plus sign. And now we factor the GCF out of these two. They both share a 7 and they both share an e. Now, let's just explore and look at this. So maybe don't copy if you're writing this down on paper just yet, because we're going to talk about this negative sign in a moment. If I just pull out a 7e, then I'm left with a negative 2x plus 3b. Now, remember that we need these things left in parentheses to be the same. You can see that they're quite close, however their signs are different. This is why we needed that negative sign to chunk together with this first term in the second grouping. If you can see ahead of time or notice that with the negatives, they're not going to quite line up, then what that means is instead of pulling a 7e out, we are going to need to pull a negative 7e out. So now I make this a negative 7e, and that means when I divide this by negative 7e, the negative signs become a positive, and I'm left with a positive 2x. But pulling a negative 7e out of the second one changes the plus to a minus. So positive divided by negative is negative 3b. And now we have the same things left in the parentheses. So you can't move on to step 3 until you can confirm that what's left in those parentheses are the same expressions. And so now that we've got all the signs correct, we will take that one common binomial that's shared and we write it one time in our answer. And then the remaining, the GCFs with the signs in front of them, come together to make your other binomial. So this is times a 5x and plus a negative is just minus 7e. At this point, we have fully factored, and again, remember, you can multiply back through to check your work if needed. Okay, so here that is worked out, and I just, again, have that typed out note there to be careful when you factor out a negative number, just making sure our signs do line up. Okay, here is our next example, and we've got, again, a scenario where the middle term has a subtraction sign. While you can rearrange this problem so that you match up terms, I do want to show you one other thing with factoring by grouping. So let's start with step one, and I'm just showing you a way we can do this without having to rearrange the terms in this scenario. Here I can group my first two together. They do share a y. Put that plus sign in the middle, and my second two I can group together, and we'll talk about what they share. It might not be as obvious, but they do in fact share a common factor. And the common factor for that second grouping is going to be a 1, or in this case, a negative 1. So here for the first two, we can pull a y out. And here you can see both signs are negative in this second grouping. Both signs are positive in the first. So to make these positive, we will pull a negative 1 out. So I'm showing you this so that we can make a note that even if, and once you pull the first GCF out, you get x plus 2, and you see, okay, this is, x plus 2, the x and 2 are the same. You have to pull something out of the second one. You can't just leave it as is and say it's done. Something has to come out. So if you're not, if there's nothing that really looks like it needs to come out, then you pull a 1 out. In this case, we needed to pull a negative 1 out. Sometimes, though, you're pulling a positive 1 out of the second grouping. You should always be getting two binomials so that y minus 1 come together. If you didn't have that 1 there, you'd have nothing there. And if you were to multiply back through without that minus 1, you would not end back with where we started. So that's why we need the 1 there, kind of like a placeholder in a sense. And then the x plus 2's. They matched up because we pulled the negative out, and you write that one time. So that's an example where you need to pull a 1 out to make those parts match. Okay? All right, so now let's start combining. So remember, with all factoring problems, we're going to be building through the methods. So the first method for factoring we learn, and we are learning them in an order on purpose, is to look for a GCF. If your entire expression has a greatest common factor, you always will start by pulling that out. Then with what's left, we will build on with the remaining methods. So in this problem, notice that a 2 is shared as a common factor throughout the entire expression. So your first order of business is to pull a 2 out of all 4 terms and write what's left from each term once that 2 is factored out. With the factoring methods, you aren't done necessarily as soon as you've just done one method. You then will continue down the methods we're learning in the order we're learning them, so GCF now grouping, and see with what's left inside of that parentheses, can that factor any further? So here we have 2VR plus 9A plus 9V plus 2AR. And we have 4 terms, so let's see if those will factor by grouping now. So we pulled the GCF out at the beginning, and with what's left, we're going to now try the grouping method. Looking at pairing the first 2 together and the last 2 together, we run into a slight dilemma in this problem. While the first 2 share a 1 and the last 2 share a factor of 1, that's all that both pairings share. So unfortunately, grouping the first 2 and the last 2 will not give us GCFs that can pull out of those groupings. However, I hope that you see that if we were to group 9A with 9V and 2VR with 2AR, those certainly would have common factors. So here is an example where it will be beneficial for us to rearrange what we have inside of this parentheses to get the terms with the 2's together and the terms with the 9's together. So what I'm going to do is recopy, and notice in each step of the way I'm bringing my GCF of 2 down with my work. And inside the parentheses I am going to rearrange so that the terms with 2's are together and the terms with 9's are together. So now when I group my first 2 and my last 2, there is a factor that can be pulled out of those pairings. Okay, I used brackets here because we are going to pull the GCF out, but we need to remember the 2's being multiplied by everything here. So the GCF of 2VR and 2AR would be a 2R, and the GCF of 9A and 9V would be a 9. So we're pulling a 9 out of the second and a 2R out of the first. Oh, okay. All right, okay, here we go. So 2R comes out, leaving us with V plus A. Bring down your plus sign. 9 comes out, leaving us with A plus V. Did we get the same thing inside of those parentheses? Well, they're in a different order, but the terms are the same. They're both A to the first, V to the first, and all of them are positive. So these are the same exact binomials. They're just in a different order. So when you finish, this is just recopied, and all stretched out. Okay, I've already shown all this work. So when you finish, you bring down your GCF that's outside. The 2R and the plus 9 come together to make one of the binomials, and that A plus V or V plus A, however order you write it in, makes up your second binomial. Again, you can remultiply all of this back out, and you should end with what we started with, that 4VR plus 18A plus 18V plus 4AR. So this example is in here to show you that when needed, you can rearrange your terms before you start the grouping method. It's also here to show you that we should always be looking for a GCF first, but we're not done if we pull a GCF out. We then need to continue and see, can we factor by the next method on the list, which is grouping. So a couple things to remember. Firstly, always look for a GCF. Can a GCF be pulled out of your expression? Next, we group from left to right. Can you group the first 2 and the last 2? Would they share a factor? If they don't, this might mean you need to rearrange your terms. Okay? So that could be needed. Also look, is there a subtraction sign in between the middle 2 terms? If so, you need to keep change opposite, or group it as I showed you, where you group that minus with the next term and put a plus in between your parentheses. And lastly, do you need to factor out a negative GCF to make all your signs match? That's the last thing to be looking for as you're going through this grouping process. So I forgot about this one. So sometimes the GCF in a problem will already be worked out for you. So in this case, if you were told to finish or to factor this expression of x times x plus 3 plus 7 times x plus 3, this is just showing that we've got the common factor of x plus 3, which can be pulled out as the 1x plus 3, and what we're left with is the x plus 7. So if you see this, which you'll see on homework for my class, it's just already halfway done for you. So don't get thrown off on a problem like that. And that's pretty much the end of our lesson. There are practice problems on the homework that if we're in class, I think we'll do together. But that should hopefully be enough information to get you started on factoring by grouping.